Welcome everyone. Today, we'll be discussing how the author's company provides cost predictions to help make sound economic decisions. We'll cover topics related to well location, depth, fixed, daily and unit costs, as well as AFEs that break down costs into preparation, drilling, testing and completion. Let's dive in. We will now delve deeper into the cost prediction and the cost specification techniques used by the author's company, as well as the authorization for expenditure, AFE. This approach enables us to divide drilling costs into preparation, drilling, testing, and completion. Additionally, we will investigate the drilling optimization techniques, such as drilling cost equations and break-even calculations, that can help to optimize and make informed decisions. Cost predictions are an integral part of our company's services, designed to assist with making beneficial financial choices. Factors such as location and depth are taken into consideration when making these predictions, as they can influence the cost of preparing the well site, traveling the rig to the preferred spot and daily operations. Furthermore, the varying lithologies penetrated depending on depth can have a bearing on the time taken to complete the well. It can be rephrased as: drilling costs increase exponentially as the depth of the well increases, and can be calculated using the formula C equals A express, BD. Here, C stands for cost in dollars, A and B are constants dependent on the well location and D is the depth in feet. This formula can prove useful for making sensible economic decisions regarding a well. Breaking down drilling costs into three distinct groups allows companies to make economic decisions regarding well location. These groups are fixed costs, daily costs, and unit costs. Fixed costs are those that remain constant throughout the drilling process no matter how long it takes. Daily costs adjust according to the duration of the process. And unit costs are determined by the amount of a specific material used during the drilling process. Fixed costs, as seen in this slide, are determined by the nature of the well. These can include the costs of wellheads, site preparation, casing, cement, tubing and packers. When the costs for these elements are projected accurately, it can help the author's company provide cost predictions that help make sound economic decisions. This slide focuses on well location, depth, fixed, daily, and unit costs, as well as AFEs, authorizations for expenditure. AFEs are used to gain further detail about costs such as preparation, drilling, testing, and completion. All of these costs should be taken into consideration when making any economic decisions, as they commonly form a large part of the total cost. Knowing precisely where these costs are allocated helps organizations make more informed decisions. Knowing the price of commodities such as barite, bentonite and others is important for cost optimization. The slide highlights the cost of units of commodities. The tendering process for these commodities is managed by the drilling manager, and with effective site supervision, it is possible to minimize excessive consumption. An adequate understanding of the different costs involved in constructing a well is essential, and AFEs, authorization for expenditure, should be divided into sections to ensure that costs are comprehensively understood. This is so that post-well assessment and comparison of costs between wells can be conducted accurately. Since drilling reached its target depth, logging was carried out and there were no economic findings associated with the well, it is proposed that the well be abandoned, with the appropriate costs allocated to it. When analyzing these costs, it is important to take into account the resources that have been allocated to the exploration, as well as the potential financial losses. Our company assists its clients in making informed economic decisions by providing cost predictions based on well location, depth, fixed, daily and unit costs, and AFEs. AFEs further break down costs into preparation, drilling, testing and completion. We offer precise and accurate cost predictions by providing an in-depth breakdown of the costs. Estimating the cost of developing new oil and gas wells is generally achievable with some accuracy. Conversely, when calculating the cost of exploratory wells, it is much harder. This is because many different service companies must be taken into account, and each involves varying expenses. Examples include drilling contractors, electric logging companies, cementing companies, casing companies, tool rental companies, mud loggers, mud companies, bit companies, wellhead companies and coring companies. The time depth graph created for the drilling program provides an estimate of the days to be spent on the well. By factoring in the charges associated with the estimated days, the AFE begins to take shape. However, some assumptions must be made when forecasting costs. For example, when dealing with exploration wells, it is difficult to predict exact expenses such as coring when limited information about the formation is available. The AFE can include either one long core or multiple runs. Using an existing database of drilling information, costs can be predicted for well location, depth, fixed, daily and unit costs, as well as AFEs that break down costs into preparation, drilling, testing and completion. During the actual drilling process, additional data is collected and then analyzed to update the database for future use, thus creating a cycle that can be repeated for optimization of costs and other factors. This process of data collection and analysis is composed of multiple steps that work together to provide an effective and efficient final result. The author's company specializes in providing cost predictions to aid clients in making informed economic decisions. Our primary concern is in the area of well location, depth, fixed, daily and unit costs, as well as AFEs that divide costs into preparation, drilling, testing and completion. We offer complete evaluations of our clients' cost-related decisions to guarantee a successful project. The process of optimizing the drilling process is not always straightforward. With the many uncertainties involved, finding the ideal solution often means making trade-offs. For instance, when making decisions about which tools to use, it may be advantageous to choose a rig with a higher daily rate to obtain superior equipment, or to invest now for future savings. Regardless of the approach, there is always the potential for achieving the best possible outcome. Optimization techniques used in drilling can help reduce costs and improve efficiency and profitability. The drilling cost equation estimates the total cost of drilling. Break-even calculations are used to determine the profitability of a well, and cost-effective decision-making combines financial data to make informed decisions about well development. All these techniques aim to make the most efficient use of resources, leading to an increase in the author's company's profitability. The cost per foot equation is a support tool that assists in determining the drill cost for a given interval. It contains 4 components: cost of the delivered bit at the drill site, cost of tools or tool repair, cost of mud to drill the interval, and a rental rig rate, as well as support costs, which includes third-party contractor rates. Combining these components gives an exact cost estimate for any drilling project. This slide is about a cost prediction tool used to make sound economic decisions, which includes information about well location, depth, fixed, daily and unit costs, and AFEs which break down costs into preparation, drilling, testing and completion. Tool rental refers to the price per hour for renting a specific tool, with round-trip time being the time it takes to pull and run a bit, and bit life being the time required to drill the interval. Non-rotating time is the time chargeable to non-drilling tasks, and the average rate of penetration during the bit run is in feet per hour. The drilling cost equation lists 11 variables. Most of these variables are interrelated, making it hard to estimate a project's results precisely. However, the equation does provide the means to take more informed and assured decisions. Included in these variables are the well location, depth, fixed, daily and unit costs, along with an AFE, or an allowance for funds expended, that divides costs for preparation, drilling, testing and completion. With this data, individuals can make sound fiscal decisions. In order to make sound economic decisions, break-even calculations are essential to understand. Break-even calculations help evaluate the amount of change in a dependent variable that is necessary to achieve a positive change in an independent variable. This allows an assessment of when costs and investments are or could become profitable. The slide showcases the typical variables that affect the alteration in bit life, rate of penetration, and trip time. It is essential to take into account certain aspects while drilling and carrying out a well, such as the modifications in bit type, drilling tools, and mud type. Having knowledge about the effect of these factors can facilitate us to accurately make preparations and budget for each well, with the assistance of cost predictions. The author's company offers precise cost estimations to help with making wise economic choices. These estimations focus on aspects such as location, depth, fixed, daily and unit costs, and AFEs that divide costs into readiness, drilling, testing and accomplishing. By looking at the costs connected with each of these stages, companies can take more educated decisions and eventually save expenses. Break-even calculations can be a useful tool in assessing whether acquiring extra rig equipment is financially viable. This equipment could prove beneficial by increasing the rate of penetration and providing other advantages. By examining the expenses associated with obtaining and utilizing the equipment and its potential rewards, we can gain insight into whether or not the equipment is meritorious. Decision-making in this field can be challenging and often relies on guesswork. We have to go with the choice that typically creates the least costly outcome. To make this determination, we need to evaluate the cost forecasts provided by our enterprise and how fixed, daily, and unit costs, as well as AFEs, can play into the decision. Examining preparation, drilling, testing, and completion can help us arrive at an economically sound conclusion. Today we will discuss the expected values method, an explicit step-by-step approach to the decision process. This method is used to make decisions by analyzing different financial returns and different probabilities of occurrence. It is a reliable way to make sound economic decisions with a focus on well location, depth, fixed, daily and unit costs, and AFEs. We'll discuss how it can be used to break down costs into preparation, drilling, testing, and completion. Expected value is the anticipated economic outcome of a project, calculated by adding the product of the cost of the first event multiplied by the probability of the event and the cost of the second event multiplied by the probability of the event. Variables CL and place signify the cost and probability of the first event respectively, while variables C2 and P2 signify the cost and probability of the second event respectively. Accurate cost predictions are essential for successful economic decisions. Cost estimates should factor in the characteristics of each well location, such as the depth of the well, as well as the costs associated with the preparation, drilling, testing and completion of the well. Knowing the fixed, daily and unit costs is imperative for the most accurate results. We can analyze the concept of break-even by examining the cost of current and prospective shakers. Break-even can be determined at $23,157, which is the maximum amount that should be paid for installing new shakers. Any amount below this sum is likely to generate a net savings. The author's company provides cost predictions to assist in making informed economic decisions, concentrating on well location, depth, fixed, daily and unit costs, as well as AFEs. AFEs give a detailed analysis of the costs involved with preparation, drilling, testing, and completion. The main objective is to give a precise cost evaluation to increase efficiency and decrease risk. The slide is concerning cost predictions. The calculation is fairly straightforward. Multiplying the rig rate with the interval time provides 8,000 times 25, which amounts to 200,000. However, multiplying the rig rate with the sum of the interval time and waiting time, and adding the RCJB rental plus the rental time, gives a more definite cost prediction. The author's company's cost predictions involve assessing various components to make informed decisions. This slide discusses economic value of a well, or EV. EV is calculated by multiplying a financial investment made in the well, denoted as C, with a percentage, P, which signifies the chance of success and return on the investment. In this instance, a financial investment of $200,000 is made in a well with a 75% probability of success, making the EV is equal to $150,000. If the financial investment is up to $204,200 and the probability of success is raised to 100%, the EV is $204,200. This slide thus demonstrates the connection between financial investment, probability of success and economic value.